AMT/ANP General Basic Electricity Test Preparation. 8001. The working voltage of a capacitor in an AC circuit should be A, equal to the highest applied voltage, B, at least 20% greater than the highest applied voltage, C, at least 50% greater than the highest applied voltage. It is C. The highest voltage that can be steadily applied to a capacitor without running. The risk of the dielectric failing is known as the working voltage. A capacitor used in an AC circuit needs to have a working voltage that is at least 50% higher than the highest voltage that will be applied to it. The working voltage is dependent on the material used as the dielectric and the thickness of the material. 8002. The term that describes the combined resistive forces in an AC circuit is A, resistance, B, reactance, C, impedance. It is C. Impedance is the total opposition to current flow in an AC circuit, including both resistance and reactance. 8002-1. What is the opposition to the flow of AC produced by an electromagnetic field, EMF, with generated back voltage called A? Inductive reactance, B. Capacitive reactance, C. Mutual inductance. It is A. Inductive reactance is the opposition to the flow of AC current caused by the presence of an inductor in a circuit. When an EMF is generated in an inductor, it produces a back voltage that opposes the flow of current, causing inductive reactance. Capacitive reactance, on the other hand, is the opposition to the flow of AC caused by the presence of a capacitor in a circuit. Mutual inductance is a property of two coupled inductors that describes the amount of magnetic flux generated by one inductor that passes through the other inductor. 8002-2. 8002-2 electrostatic fields are also known as A, dielectric fields. B, electrostatic fields, C, static fields. It is A. A charged body is surrounded by a field of force. This is an electrostatic field, which is also referred to as a dielectric field. It is illustrated by lines that branch out from the charged body in all directions and come to an end where there is an equal and opposite charge. 8003. The basis for transformer operation in the use of alternating current is mutual A, inductance, B, capacitance, C, reactance. It is A. Transformers work based on the principle of mutual inductance, which is the property of two inductors that describes the amount of magnetic flux generated by one inductor that passes through the other inductor. In a transformer, two coils of wire are wound around a common magnetic core. An AC current in one coil produces a changing magnetic field, which induces a voltage in the other coil through mutual inductance. The voltage induced in the secondary coil is proportional to the ratio of the number of turns in the primary and secondary coils and can be either stepped up or stepped down depending on the relative number of turns in each coil. Capacitance and reactance do not play a direct role in transformer operation. 2004. The opposition offered by a coil to the flow of alternating current, ignoring resistance, is called A, impedance, B, reluctance, C, inductive reactance. It is C. Inductive reactance is the opposition offered by an inductor, coil, to the flow of AC current, ignoring the resistance of the coil. It is caused by the back EMF, electromotive force, generated in the coil as a result of the changing current. The back EMF opposes the flow of current and reduces the current flow, resulting in inductive reactance. Impedance is the total opposition to the flow of current in an AC circuit, including both resistance and reactance, while reluctance is the opposition offered by a magnetic circuit to the establishment of a magnetic field similar to resistance in an electric circuit. 8004-1. What factors strengthen a coil inductor? A. Limiting and separating the coils. B. Adding and separating the coils. C. Adding coils close together. It is C. The strength of an inductor, coil, is determined by several factors, including the number of turns of wire in the coil, the diameter of the coil, the material of the core, and the proximity of the coils. Adding coils close together, or increasing the number of turns in the coil, increases the magnetic field strength and hence the inductance of the coil. Limiting or separating the coils can have the opposite effect and reduce the inductance. Therefore, option A is not correct. Similarly, adding and separating the coils may not necessarily strengthen the coil depending on the specific configuration. 8005. An increase in which of the following factors will cause an increase in the inductive reactance of a circuit? A. Inductance and frequency. B. Resistance and voltage. C. Resistance and capacitive reactance. It is A. The inductive reactance of a circuit is directly proportional to the inductance of the inductor and the frequency of the AC current flowing through the inductor. In other words, an increase in either the inductance or the frequency of the current will result in an increase in the inductive reactance. Resistance and voltage do not directly affect inductive reactance, although they may affect the overall impedance of the circuit. Capacitive reactance, on the other hand, is caused by the presence of a capacitor in the circuit and is inversely proportional to the frequency of the current. 8006. When different rated capacitors are connected in series in a circuit, the total capacitance is A. Less than the capacitance of the lowest rated capacitor. B. Greater than the capacitance of the highest rated capacitor. C. Equal to the sum of all the capacitance. Refer to Figure 1. It is A. When capacitors of different values are connected in series in a circuit, the total capacitance is less than the capacitance of the lowest rated capacitor. The formula to calculate the total capacitance, CT, of capacitors connected in series is given by CT in 1 C1 plus 1 C2, 1 C3. In this formula, C1, C2, C3, etc. represent the capacitance values of the individual capacitors connected in series. Since the denominator of the formula involves adding the reciprocals of the individual capacitance values, the total capacitance will always be smaller than the capacitance of the lowest rated capacitor. This is because the sum of reciprocals is always larger than any individual reciprocal. Therefore, the correct answer is less than the capacitance of the lowest rated capacitor. 8006.1. Capacitors are sometimes used in DC circuits. 2A. Counteract inductive reactance at specific locations. B. Smooth out slight pulsations in current voltage. C. Assist in stepping voltage and current up and or down. It is B. Capacitors are commonly used in DC circuits to filter out or smooth out small variations or fluctuations in voltage or current, which are also known as ripple. When a capacitor is connected across a DC power supply, it charges up to the supply voltage and then discharges when the voltage drops below a certain threshold. This process helps to even out the fluctuations in the voltage or current, resulting in a smoother and more constant output. Capacitors can also be used in AC circuits to counteract inductive reactance at specific frequencies, as in the case of a tuned circuit or filter. However, this is not typically done in DC circuits. Capacitors are not typically used to step up or step down voltage or current, as this is the function of a transformer.